Hello, and welcome. My name is MiniBetrayal, and this is Molek-Syntez, or something of that ilk. I'm not entirely sure how to pronounce it. I don't speak Romanian, I think. I saw on Twitter this game is supposed to be set in Romania, but I believe that translates to something along the lines of molecular synthesis, and that is, well, I was going to say that's the name of the game. That literally is the name of the game. It's also what we're going to be doing today. Now, I have played a little bit of this game already, so I've got a reasonably good idea of what's going on. This is the latest release from Zachtronics of Opus Magnum, Infinifactory, and Shenzhen IO fame. It's actually the first of their games I've ever played myself. I've been meaning to get around to a Zachtronics game for ages, but just haven't really. So yeah, before I go into the actual game, firstly, my mic's been doing some weird things lately, so you may notice the sound is a little different. Let me know if it's better or worse or not. Also, I have a Discord now, link in the description if I remember to put it there. Come along, have a chat. I'm nearly always online. I'm either online or asleep or dead. But yeah, come along, have a chat if you have any questions or just want to talk to me or other people in the Discord. If you decide to become a patron, there's also special perks in the Discord channel there as well. Anyway, let's launch straight into it. As I said, I've done some of these already. This top row here I have already done. What we have to do, let's just start a new solution here. So if I open that. So this is the grid here. And our goal is to manufacture copies of this drug molecule. So this is hydrogen peroxide, or H2O2. The way we do that, we go to this precursor catalogue, where we've got, at the moment we've just got water, but we've got a bunch of other things as well. Click on that and we can put it in there. Then what we can do, we can use these different instructions down here. So at the moment we've got 6 different instructions. We can push and pull, we can move left and move right, we can remove a hydrogen atom, and we can output the target. Then on the left here we have a grid. We've got 6 different columns. Each of them correspond to one of these emitters around the edge, these particle beam emitters. So we need to turn this water atom, or water molecule I should say, into a hydrogen peroxide. So one way of doing that, if we get 2 of them, put them next to each other, and then in column 1, so from this beam 1 emitter, what we can do is remove our hydrogen atom, and if we do the same from number 4, or if I just use a shortcut by pressing F and clicking, then if I just move 1 step forward so you can see what's happening, we've got our molecule and the bonds just sort of sort themselves out. Now if I don't do anything else, it's just going to remove the other one and nothing else will happen. But what we can do, once we've got it, in the second row, if I just get one of them to output the product, so step 1, it makes our hydrogen peroxide. Step 2, we output it, and then we get our original waters back. Now it's a little bit difficult to see in this situation, but these 2 spots, that's where I've put my precursors. Once the spot is empty, it sort of fills up again with the precursor, so it fills up with the water again. So as soon as I export the peroxide, I get 2 new waters and we go again. So looking down here, our quota is 120. We need to make 120 of these things. Cycles is, I believe it's just how many steps it takes. So at the moment, each time it takes us 2 steps to make 1 peroxide molecule. Modules, now I'm not entirely sure on this. I believe modules is the number of precursor slots we have plus the number of columns we are using, or the number of beam emitters we are using. Wow, that was a sneeze. Where was I? Oh yes, modules. So precursors plus beam emitters is modules. Symbols is literally how many instructions we have over here. And what we can do, we can just try to get it to work. So this runs it through step by step. This will just play continually. And you can see we've got quota and cycles ticking up there. And this button here will just run it fast until it goes to the end. So you can see 240 cycles, we can do better. Modules, we can also do better there as well by the looks of it. Symbols, I don't think we can do much better. In fact, if I go back to the menu and just pop into settings there to turn on percentiles, we'll go back to that. So this is our solution. We'll run it again. So you can see here the top percentile. We can do this in 80 cycles. We can also do it in 2 modules. At the moment, this solution is using 4 modules, but I have already done it in 2. And then symbols, 3 is the best we can do. So let's keep editing. How can we reduce this down to 2 modules? Well, the easy way of doing that is like this. So if I get rid of that, so just right click to remove. Okay, so we've got our 2 modules. We have a precursor and we're just using 1 beam emitter. So if I say take off a hydrogen and then push, so we'll take off a hydrogen and then the next step it'll push it away from us by 1. That clears out the precursor spot, so we get a new water molecule. So we take off the hydrogen, we push, we take off the hydrogen again, and we've got our peroxide and we can export it. Like that. So let's run that. And there we go, down to 2 modules. Now, how can we improve on cycles? So my best is 240. This one did it in 480. Let's see, as I said, my best is 240. That means we can do better. Well, I think if I get another water and pop that there, we'll go back to like the first solution, which was that, I think. Was that it? Yep. But we've got another 4 emitters to play with here. And we can move these around as well. So if I do something like that, I just tried to press Q to use the pipette tool, but no, this is not Factorio. So we can do a similar kind of thing there. So if I set the same instructions up on on 2 and 5 and output, so that will make 2 at once. And of course, we've got a 3rd set over here as well. So I just need to do exactly the same again. I'll just put these ones down here, make sure they don't get in the way of each other. Like that. Run it. And we're down to 80. Excellent. Now, this one, even though it's better on cycles, is kind of awful on modules and symbols. But let's exit to menu. And in fact, because I don't have a best cycles yet, let's rename that. Best cycles. Rename. So yeah, this was my first go at the game. Yeah, so I've just got a spare one sitting there for no apparent reason. But anyway, there we go. Exit to menu. Yeah, but I've got best modules, best symbols, and best cycles. And you can see the different stats for each of them there. And then they start to get a bit more complicated. Like, let's have a look at this one. So I've got solution and I've got best cycles. So this, actually, let's look at best. Just look at a solution first. So we need to make nitrous oxide, which is this, and we've got the whole list of precursors to start with. So I used, I think I just started off by using ammonia and water, so just basic nitrogen and oxygen with hydrogens around them. And essentially I just strip off all of the hydrogen atoms like that, then like that, and then export it. So there you go. So it's good on cycles, that one. It's about as good as you can get. Or according to... no, actually it's not. 360, best is 240. There we go. So It's not bad on symbols. Modules could be better. It's possible in 2 modules? I suppose it would be possible in 2 modules. Yeah, you just have to start with something that's already got nitrogen and oxygen in it and do a lot of fiddling around. So yeah, if you start off with this carbamide, yeah, you'd have to start with that one and then do lots to it. But anyway, yeah, just simply by just doing 2 of them at once, you can decrease the cycles down to 240, which is the best. Okay, so they did start to get a bit complicated. This one here, I spent probably a good 45 minutes on. So we've got to make this. Now, the solution itself wasn't that difficult, but I wanted to get it in the best possible modules. So this is an example of how you can take just a single precursor and a single beam emitter and make something like this. So I'll step through it first. So you can see we take off a hydrogen, and then we move the emitter, and then we add 3 hydrogens. The reason we do that is it gets rid of the bonds to the oxygen. We then move the beam emitter again and just straight up delete that oxygen. We then move back. We take off a hydrogen, which puts that puts back that bond. Move back. We can then rotate the whole molecule about the one we're pointing at. So we do that twice. And then pull it towards us. That clears off the precursor spot. So we get another... What is that? No, that's not ethanol. Some kind of acid, ethanoic acid, maybe? I'll find out in a minute. And then... Yeah, we then move. Push that one away from us a bit. So we can rotate it. So that carbon is facing us. We can then get rid of that extra hydrogen we don't want. Rotate it a couple of times. Pull it back into position. That both clears the precursor spot and actually makes the molecule we want. We'll then export the molecule and then just move that back to where we started. And there we go. So yeah, this one, a lot of cycles, way up here, but 2 modules. And it's surprisingly not bad on symbols. 22 is quite a lot, especially when you compare it to the top percentiles. But because it's just the one column, it's not too bad. Okay, so let's try one that I haven't already tried. So this chloroform. Fun. Okay, so we need a carbon and 3 chlorines. So what should we start with? So does chlorine come in anything other than the hydrochloric acid? No, I don't believe it does. Acetic acid was the one from earlier, by the way. So we definitely need at least... let's just go for a simple one first. So let's get 3 chlorine or 3 hydrochloric acids. We'll need to pull the hydrogens off. And then we need something with a carbon in it. Let's just get methanol. Okay, so let's point that. So point number 3 at the carbon. And we'll pull off 2 hydrogens. We'll then move it to... Which way is that moving? So we'll pull off 2 hydrogens. Yeah, we'll then move it that way. And then what we need to do is to get rid of the oxygen. Now, there is just a kind of delete key. But if we do that at the moment, it'll actually delete the whole thing. So what we actually want to do is separate off the oxygen first. And the way we can do that is by adding a hydrogen atom to that oxygen. So you see if we do that, we'll add that. Now the oxygen can't have any more bonds, so it sort of disconnects from the carbon, and then we can delete it. And then, you know what, we may as well use the same one again because it's already pointing in the right place to remove the hydrogen atom from the hydrochloric acid molecule. Okay, then we just need to get rid of these extra bits, the extra hydrogens. So we'll use 1, and if I just move that up there, we can use 6 as well. Then once we've done all that, we can export it, and then we just need to move 3 back to where it started. Okay, so that seems to be working. Run through it. Okay, so cycles isn't so good. Modules can do better. Symbols can do better. Let's see. Let's see if we can get cycles down. I think that'll be the easiest one to do here. So, actually, let's just save this as a solution first up. So, rename. I'll just call it solution. Okay, and then let's copy that and open this new one. Okay, so we want to get cycles down. I think the best way to do that, if I use 2 to get rid of a hydrogen, no, to get rid of a hydrogen. 3 will get rid of a hydrogen. 4 will add a hydrogen. And then delete. Is that good? I don't know. 5. I put 5 there. 5 can remove a hydrogen. No, that's not remove. There we go, remove a hydrogen. How far does that get us? So actually, I can export on the same step I remove the oxygen, because we'll only export what we pointed at. So as long as I don't export from number 4, everything's fine. So let's just export from there. Yeah, that's working. And there we go, down to 240 cycles. So let's rename that one to best cycles. Okay, dimethyl sulfoxide. In fact, let's see if we can do a really complex one, like aspirin. Okay, so what do we need for this? We'll need a benzene ring. That's a benzene over there. So we'll need that. Then looks like we've got acetic acid. You can rotate these, by the way, as well. So, okay, so we sort of need to get rid of that carbon and mush it onto there. And looks like we've got another acetic acid down here as well. Interesting. That's flipped. Yeah, because you can see the double bond goes that way. We actually want it to go down. Is there a different one I can use? I think I do have to use it. I just have to fudge around with the bonds a bit. So, let's see. So if number 1, if I add a hydrogen on that, that should break the double bond there. Okay. And then if I move that over a bit and subtract a hydrogen. Okay, so that moves my double bond. If I then move it back and subtract a hydrogen, I think. Let's try that. Okay, so we've got an open oxygen there. If I were to just push that forwards, that would then bond to this, but we need to get rid of the hydrogens from those two first. Okay, so if I actually put that there, and just start that down there. Then number 2. Okay, slight change of plan. Number 1 I'm going to leave up there. I'm actually going to do that with number 5. Firstly, because it has to move less. So number 5, if I add... in fact, I can probably be even more clever about this. If I remove first, starting from there, then move, then add. What does that do? So let's clear off that. So remove. Okay, and then if I just remove that straight away. Yeah, okay, so that leaves this one open and switches the double bond to where I need it to be. Okay, while that's going on, let's use number 1 to get rid of these 2 hydrogens that we don't want. So that will go get rid of that, move, and get rid of that. So looking at number 1, that should get rid of those. Ooh. But that makes this one a double bond. I don't know if that will work. So if I after doing that, if I use 6 to push this to there, will it connect to the benzene? No. Okay, so I can't actually do that yet. So let's start one there. So that should connect up, and that gives us sort of this bit. Okay, then up here I need to get rid of this carbon. So I think with number 4, if I can do this at the same time, I think. If I add a hydrogen and then delete, so that should give me, yeah, free floating carbon, then get rid of it. And then I need to wait at least until that step before I remove the hydrogen from that carbon. Okay, so that step there, I think I can do that, so I need to move that. Let's make sure that that works and we don't end up with the double bond. Okay, that's good, we don't end up with a double bond. And then I just need to push this into place, I think. So I'll get number 2. Push, push. Okay, so yeah, we've got another acetic acid up there. And just make sure that's right, and then yeah, if we use, say, number 4 to sell it. There we go. Oh, no, not quite. So what happened there, I forgot to move these back to where they started. So on this step here, I just move that back that way, that back that way. There we go. Okay, so yeah, I can halve my number of cycles and do better. I'll save it. I'm not going to optimize that one just yet because optimizing it will probably take a bit longer than I would like. But I'll just call this one solution. Propofol. Let's try this one. So it's the hardest one I have access to at the moment, or in theory, it's the hardest one. Open. Okay, so we've got a benzene there. We need to start with that. Then attached to that up there, we've got a propane bit. So I'll just put these in roughly the right places to start. Okay, so I've got a double bond there I need to break. Random oxygen. So easiest way to do that is from a water. There. And then another propane section there. Okay, so what do I need to do? I need to get rid of the hydrogens on these 3 carbons. I need to get rid of a hydrogen from that oxygen. I need to add hydrogens to this one and that one. So this one here is going to be the tricky one, because if you look at it, it doesn't have line of sight to, well, anything at the moment. So I think if I actually start that one there, okay, and the very first thing number 1 will do is remove that spare hydrogen, and then on the next step that can move over that way and remove a hydrogen again, and that should fuse the oxygen atom where it wants to go. Excellent. Okay, then if I start 6 there, yeah, I can't do that right at the very beginning, because if I remove that hydrogen straight away, we end up with a double bond there. So let's not do that. So if I put it on that step instead, yeah, okay, so that's all right. And then, in fact, what we can do, rather than do that one first, if we take care of this lot first, so instead go there, we'll add a hydrogen up there, and then push it. Oops, one step at a time. So add a hydrogen, push it, and then, yeah, we need to move it to the right. So add a hydrogen, push it, move it to the right, and then take off that hydrogen. Then that gives us this group down here. Excellent. And then, see, if I use number 2 over here, over there. So first up, get rid of that hydrogen, then move, then add a hydrogen. So, oh, we end up with a triple bond there. That's inconvenient. Okay, so maybe we can do the same kind of trick. If instead of doing it that way round, let's do it that way round and instead move that way and start there. So you add the hydrogen first. Oops. Add the hydrogen first, then move. And I think that's our atom. Molecule. Not actually. That's our molecule. Yeah, everything looks right there. Okay, so then we just need to export it and move our stuff back to where it started. So actually, if I export it on that one, then you want to go that way, you want to go that way, you want to go that way. Oh. Why doesn't that work? Ah, okay. So I do actually have to... think I can do that. Yeah. Alright, there we go. So, yeah, again, could do better on cycles, better on modules, better on symbols, but yeah, that wasn't me trying to be efficient. Am I not capable? Powerful? Am I not dangerous? Yes, I am, and yet they ignore me. So yes, there is an interesting little story going on as well. You get the first few sections of the story as you go through the first puzzles. I won't spoil it too much, but it's interesting and kind of dark, mysterious. But anyway, it's a game I totally recommend it, and I will certainly be playing more of this. Maybe I'll do it on videos. I might even do a stream. I don't know. Also, there is just a random solitaire game. because why not? And yeah, you can play solitaire. That one doesn't go there. Oh, I've screwed it up already. But yeah, so it's a version of solitaire anyway. But I'm going to leave it there for this episode. Well, I say I'm going to leave it there. I'm probably going to go and play this for another few hours. In the meantime, I will say thank you very much for watching, and I will see you again soon.